Welcome to today's video. Today's video is for Advanced Geometry, Chapter 2, Section 5, Proving Angles are Congruent. I like this section because it's the first section that we get to do an actual proof in, so you'll get to see your first proof. I will do one of the proofs in this section just to show you what it looks like, and the other ones we'll do in class together. So first thing we have is a theorem. A theorem is a statement that can be proved. And we already learned about postulates, and we've had some postulates. Postulates are statements that are not provable. Most of our proofs we will do as a two-column, so I'm going to add two-column here. When you write a two-column proof, you make two columns and you put all your statements in the first column and you put all your reasons in the next column. It's a nice way of writing proofs because it's very organized and you can really see how your statements flow and make sure your reasons match. The disadvantage with it is out in the, in college or beyond this class, most proofs are written as paragraphs. So it's not the way that commonly proofs are written. But we'll write them this way because it's nice and easy to keep ourselves organized, especially when we're just learning how to do proofs. Okay, so our first theorem. Vertical angle theorem says that vertical angles are congruent. Okay, so we have definition of vertical angles that would say, for example, that 3 and 4 are vertical angles, and then vertical angle theorem can say that they're congruent. So one of the things we could say is angle 3 is congruent to angle 4, and our reason could be vertical angle theorem. So it's a theorem, which means we can prove it. So I'm going to do a two-column proof, so statement and reason. So we're given angle 1 and angle 2 are vertical angles, and we want to prove that angle 1 and angle 2 are congruent. Now, one of the first things I notice in this picture is they gave me angle 3. They must have given me angle 3 for a reason. I can label the other angle, angle 4, if I want and use it, but the fact that they gave me angle 3 is kind of a hint that I probably am going to use that angle 3. So the first thing I'm going to start out with is my given. You don't have to start out with your given, but in this case, I am going to use it right away, so I'll use it. Angle 1 and angle 2 are vertical angles. And my reason is, it's given. Now, if I take a look at angle 3, I notice that these are supplementary, and I also notice that these are supplementary. Now, that's one of the assumptions I'm allowed to make from a picture, so I don't have to say angle 1 and angle 3 are supplementary, and angle 2 and angle 3 are supplementary. I'm allowed to look at the picture, assume that's true based on the picture. Now, what I actually want to do is change that into a mathematical statement. I want to say that the measure of angle 1 plus the measure of angle 3 equals 180. And the reason for that is definition of supplementary. Now, I also want to do that for 2 and 3. So I don't need a separate reason since it's the same reason. What I'm going to do is I'll just put a semicolon and I'll put it right below. So measure of angle 2 plus measure of angle 3 also equals 180. Okay, now when I look at what I have, I notice that both of these on one side have 180, which means I can use either substitution property of equality or I can use transitive property of equality. And what I can do is I can say, well, if measure angle 1 plus measure angle 3 equals 180, and measure of angle 2 and measure of angle 3 equals 180, well then measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3. And I'm going to call that substitution property of equality. I'm taking out one thing that is equal and putting in the expression that's equivalent to it. I'm going to go over a little bit. That's okay. Okay, so for 3, this is substitution property of equality. Now remember, there's no substitution property of congruence, so if I wanted to do that step and it involved congruent things, I'd have to use transitive. Okay, now I notice that, measure of angle 3 and measure of angle 3, if those are the same measure and they're just numbers, I can subtract them from both sides. So step 4, measure of angle 1 equals measure of angle 2. And this is subtraction property of equality. Now notice that I do abbreviate, but for substitution and subtraction I have to give at least a little bit more because I need to distinguish between substitution and subtraction. So I'll put like SUBST and SUBTR. And we're not done yet though. It doesn't want to know that their measures are equal, it wants to say they're congruent. So I need one more step to say, well, the definition of congruent angles says if the measures are equal, they're congruent. Now this is a definition, which means it is reversible, and I can either use definition of congruent angles to say that if they're congruent, their measures are equal, or I can also use it to say if the measures are equal, they're congruent. So this is definition of congruent angles, and I am done. Okay. So our first proof, take a look at it, see if you have any questions, and we can go over it tomorrow. Now the next one says find. Find is not proof, it just means find the value of x. I don't need statements and reasons or anything like that. So I take a look again, oh, they're vertical angles, which means they're congruent, which means their measures are equal. So I can say that 4x equals 3x plus 35. Subtract 3x from both sides, and x equals 35. Double check, did they ask for anything else? Nope, so I'm done. The next theorem we have is congruent supplements theorem, and this is one I'll prove in class. It says if two angles are supplements of the same angle, or of two congruent angles, then the two angles are congruent. So suppose I have a picture that looks like this. So I have 1 and 2, and then over here I have another angle, we'll call him 3. And suppose I give you that, so I'll put given, that angle 1 and angle 2 are supplementary, or in this case, we're allowed to assume that. Or I also need to give you that angle 2 and angle 3 are supplementary. Okay. So I can assume that angle 1 and angle 2 are supplementary. That's part of one of the assumptions I'm allowed to make from a drawing. And then I give you that angle 2 and 3 are supplementary. So both 1 and 3 are supplementary to 2. I am allowed to say that angle 1 is congruent to angle 3. And my reason would be congruent supplements theorem. Okay, we have 3 more theorems. Now one is named by the book, and that's why it's in the nice writing, and we'll add names for the other 2. The next one is a congruent complements theorem. It's the same thing except for, as the previous one, except for it deals with complementary. If 2 angles are complements of the same angle, or congruent angles, then the 2 angles are congruent. So if I draw something like this instead, and I have 1, 2, and then over here I supposedly I have angle 3, and then I draw a little right angle symbol in there, and it's given. I can say that, you know, angle 1 and angle 2 are complementary, and then I can also suppose I'm given that angle 1 and angle 3 are complementary. Well, if 1 is complementary to 2 and 1 is complementary to 3, then 2 and 3 must be congruent. Okay, the next one is all right angles are congruent. Okay, this one I like to just call right angle theorem. Okay, so if you have any right angles, you don't have to change them to measure equal 90 and then set them equal to each other and then change back to congruence. You can use right angle theorem and say that if they're right angles, they're congruent. Now the last one says that if two angles are congruent and supplementary, then each is a right angle. And we've had this one on a quiz where it was like an always, sometimes, never. So if two angles, and then remember, they don't have to be adjacent, but I'll draw them as adjacent. So if I give you that angle 1 and angle 2 are supplementary, so this would be a given. And I also tell you that angle 1 is congruent to angle 2. You can say that angle 1 and angle 2 are right. You can't say they're 90 degrees. You'd have to use definition of right angle to do that afterwards, but you can say that they're both right angles. So we'll prove these, at least a couple of these in class, and then if you have any questions, you can let me know. Thank you for watching my video. Take care.